In September 2022, security researcher Gavneet Amiga reported a vulnerability she found in the Microsoft Azure Cloud Shell. In a blog post, she described that by exploiting this vulnerability, she was able to take over an Azure Cloud Shell trusted domain. By this, she was able to access other users' terminals and execute her own commands there. By this, she was also able to retrieve the user's access token by finding her way to access the metadata service that is attached to the shell terminal. After obtaining those access tokens, she could use those tokens to perform actions on the victim's behalf. The vulnerability that led to this is called command injection. But what is command injection? In this video, you will learn what exactly a command injection vulnerability is and how the exploitation of it works. Also, I will provide some countermeasures you can implement to protect your application from being vulnerable to command injection attacks. What is command injection? Command injection is part of the injection attack spectrum right next to attacks like SQL injection or cross-site scripting. Thus, it is currently listed third on the OWASP top 10 list of web application security risks. Injection vulnerabilities are incredibly widespread, and according to the OWASP Foundation, 94% of applications that were tested contained some sort of injection vulnerability. A command injection vulnerability is a web security flaw that attackers can exploit to remotely run operating system commands on a server that is hosting an application. It is also known under the name shell injection, as it usually contains shell commands. The results of this attack can lead to compromising both the program and all of its data. Additionally, if the attacked server is able to freely communicate with other systems in the backend, the attack can also be extended to a whole infrastructure system. An attack like this can happen when an application sends unsecured user-supplied data, for example in form of forms, cookies or HTTP headers, to a system shell which is then executed. Before we head on, you might have already heard of a similar attack that is called code injection and wonder where the differences are here. The main difference between code and command injection is that for a code injection attack, the attacker writes their own code that is executed by the application. On the other hand, command injection describes the exploitation of system commands that are already part of the default functionality of the application. So how exactly does that work? Let me explain it to you with this example. Let's say we have this website where a user can use the search feature to look for a certain product. The variable the user put into the search function will then be used by the application to search a database. A code that would be vulnerable to a command injection attack could look like this. This is the code the application uses for that search function. First, the keyword is retrieved and afterwards the command string is generated and sent to the shell. In this example, the command string uses the grep command to search the product list txt file for the keyword provided by the user. If the user input is directly sent to the system without any proper validation, an attacker now could exploit this vulnerability by including malicious commands into the search function. An example for that could be this. A malicious user enters apples rm-rf into the search function. The application will then insert the user's input into the command string, so the resulting command will be grep apples rm-rf product_list.txt. But when the application runs the script, the program will not only search the product list file for apples, but will also run the rm-rf command. This command is used to remove files from a directory, and also by using the flag f, the system will also remove read-only files. This command combination is able to wipe out all data that is saved on the system. This example would lead to a denial of service attack, but by using a different search input like apples cat etc. password, an attacker could exploit the command cat to retrieve the contents of the etc. password file. There are additional commands attackers could use to retrieve information about the system they're trying to compromise. If a command injection vulnerability exists, the following commands might be helpful. We can check for the name of the current user with the command whoami. Also, depending on the operating system, we can use commands like var to find out details on the operating system, as well as the network configuration with the command ifconfig. Also, there are a few others you can see in the table here. Alright, let's leave the theory and let me show you how performing a command injection attack could look like. So let's head into the demo part of this video. Alright, welcome to the demo part of this video. For this demo I'm using the Portswigger Web Security Academy lab. Those labs are deliberately insecure websites provided to practice web security attacks on a legal basis. If you want to check it out yourself, I will put a link in the description of this video that will take you to the command injection labs of this page. So we have this online web application, and for each product there's an option to check whether the product is in stock in a certain store. So the first step is to choose a random store. Let's go by London. And trigger the check stock request. In the next step, we're opening Burpsuit to get details on the request. If you want to learn more about Burpsuit, I put a link in the description where you can find out more details on what this software can do. Now, and once we found the request, we can examine it a bit. So down below where we can find the variables that were sent to the server with the request here. Those are the product ID as well as the store ID. Next, we use the burp repeater function to inject our malicious query into this request. To do this, we'll just right-click the request and click Send to Repeater. Now we can switch to the Repeater tab, and here we can make changes to the original request and resend it. So for the first example, we go down to the variables, and here I just add a pipe and the command whoami to the original request parameters. As I explained earlier, the whoami command shows us the name of the user that is currently connected to the shell. After resending it, we can now examine the response. And we can see here that the username of said user is Peter DIBPC5. As mentioned, there are different command options that can be used in this scenario. Using the whoami command was the solution to this lab. As we can see here, congratulations, you solved the lab in the web page. But I really want to find out if I can inject any other commands here as well. I want to know what operating system the server of this application runs on. But since I don't know which one it is yet, I have to try both the commands for Windows, which is var. So let's put it in. And also the one for the Linux one if the Windows doesn't work. So let's send it. And as we can see here, var is not found. Now, since var gave us an error message, as a result, let's try the Linux command, which is uname-a, and we can resend it. And here in the response, we can see that the operating system is indeed a Linux, and we also get some other specs too. So I hope this demo helped you understand the theory of a command injection attack a bit better. Now let's get back to the video, as you probably wonder what countermeasures can be implemented to prevent your application being vulnerable to this kind of injection attack. A command injection attack can lead to multiple different outcomes, and the impact of a successful exploitation can range from the attacker compromising the application to sensitive data exposure. Fortunately, if you are aware of this vulnerability, there are some precautions you can take and defenses you can build into your web application to avoid them being vulnerable to command injection attacks. Let's start with the most obvious measure you can take to avoid any command injection vulnerabilities. Never call any operating system commands directly, especially not when they contain any user-supplied input. Depending on the language you're using, you can use functions from additional libraries that can't be manipulated but perform the same tasks. An example for that would be the function mkdir instead of system mkdir/dir name. Another countermeasure that I always recommend when it comes to any kind of injection attack is input validation. The first thing you should do when there's any kind of user input involved is validating the input first thing on its arrival. By implementing an input validator, you can easily avoid letting your application even process malicious content. Another advantage of that is that you can also improve the usability of your app by making sure the user puts the correct data into the input fields. In case of a whitelist, you generate a list of allowed commands and check if the input contains any of that. If not, your application should reject the input. You should also check if the input contains any shell meter characters like semicolons, ampersands, or pipes. If you've seen my video about SQL injection, you probably already know about parameterization as a countermeasure against injection attacks. This also works with command injection vulnerabilities. Parameterization means that the command and the user input are treated as two separate elements. This way, the application knows that the user input is an element it shouldn't execute as an operating system command, but rather as a simple variable. To bring back the example from earlier, if an attacker would put apple semicolon rm minus rf backslash into the product search bar, with parameterization, the application wouldn't execute the rm command, but rather search the product underscore list txt file for the whole string. As a result, the attacker wouldn't get anything in return. There are many additional defense measures that can be implemented to protect your application against any code injection vulnerabilities, but those three are the most important ones. If you're looking for details on the mentioned countermeasures or want to learn about the other options, I put a link in the description that takes you to the OWASP cheat sheet about command injection defense. Now, to put everything together, I hope after watching this video you have a better understanding on what a command injection vulnerability is. The exploitation of such a vulnerability can lead to several negative consequences, like a denial of service in case the attacker manages to delete any files on the system, or the disclosure of confidential data. It is just as important to prevent your application and system containing such a vulnerability as it is easy to implement countermeasures. Always secure your application against any type of injection attack by implementing input validation and parameterization, and always avoid calling any OS commands directly. You will find all the links to the resources and websites I mentioned in this video in the description. If you're interested in learning more about web security, consider subscribing to my channel so you don't miss out on any new uploads, and feel free to check out my other videos. Also, if you found this video helpful, please leave a like. Until then, I wish you a delightful day and see you soon in the next video. Goodbye.